so stirrup doesn't get in trouble. So I heard like if you're caught without your IDs outside of my class, you're all, ninth period of the day, you're like, yeah, I got stirrup. So it's always my fault. All right. We are going to start getting into something called stem plots, dot plots. This is relatively easy, and it's just a way of just looking at the shape that your data would make. That's all it is. I'm on page 11 in the notes. And so, stem plots, they sometimes call them stem and leaf. They mean the exact same thing. And how it basically works is this. Let's say I had a sequence of scores on some sort of test. So let's say these are just scores from some test, quiz, activity, whatever. If I wanted to create a stem and plot, first thing I'm going to do is the stem is, for the most part, one number. Okay? So the stem of it, if they call it stem and leaf, then the leaf could be multiple numbers. So what you would do on this is I'm going to look at my first numbers. Okay? And so I have 2, 3, 4, and 6. Okay? Now, I could squeeze the 5 in there, but there's not going to be anything to it. So it's not right or wrong if you include the 5 just to keep the sequence of numbers. It's not wrong if you include the 1 and the 7. And this basically what you do with this is this. Okay, I have a 25. I have a 27. I have a 28, 28, and a 29. Okay? So if you looked at that green row, you'd say, okay, my scores are 25, 27, 28, 28, 29. And then I go to 30. All right, 0. I got a 1. Go to my 40s, 45, 46, and then I have a 60. Okay? Now notice I'm using the 0 for 60. That doesn't mean I don't have pieces of data in there, but this has a certain shape. It looks like more numbers happen to be in the 20 range than any of the other numbers. And again, numbers that aren't vital to have on this, you don't need to have necessarily these. This one is a good optional one to have. I'm not going to count it wrong if you didn't have it, just because it's inside the numbers. But the 1 and the 7 you really don't need, but it's up to you if you want to put it. Okay, and again, all the stem plot is a way of looking at your data saying, is there some sort of shape to it? That's all it is. It's not anything amazing. So some of the questions that they have from the thing, how many scores would be represented from the one above? And you would literally just count the numbers to the right of the bar. So if you wanted to see how many numbers I included here, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 numbers. Okay, I'm not worried about the stem part, the left side. The right side counts us up the numbers. You want them to be in order. Okay, and so those are just a couple things. So this 25 on my example, I know it's not in the book, that's our lowest score. And this 60 is our highest score. And everything else is in between them. Okay? All right. So I said some terminology saying this is to look at our data to see some sort of shape. So if I were to look at this, there's going to be something we're going to eventually get to called a normal curve. Okay, normal curve looks like this. If I tried to make a normal curve with the information I have, it actually looks something like this. Okay, if I were to turn it on its side. Okay, so this is what my data looks like here. This is called a normal curve, meaning the normal curve should have symmetry about it. The highest point should be the mean and the median, which we'll talk about those tomorrow. But that's basically what we're doing. When we say what type of shape, what do we see from our information? Let's see. I'm just trying to see if there's anything vitally important for us. All right. So then the next thing is the dot plot, and that's on page 12. And the dot plot is the same idea, but the dot plot itself doesn't have all of the values. So if I were to go back and go dual screen, view. If I were to look at my original data, and if I made the dot plot, same idea, where I'm going to have let's see. All right, so I'm going to go 25, and I'm going to count by, say, twos. 31, 33, 35, 37. And I'm going to run out of room on this one. But basically how this is going to take place is like, okay, I have one dot at the 25. 27 and 28 are counted here. 29 is counted here. 30 is also counted here, so you're going to the left. 31 is counted here. So on and so forth. So the dot plot is a way of acting like it's a stem plot, but you kind of make it horizontal, and you just kind of start putting tick marks where certain things are. Okay? So a dot plot could look something like this, where this would represent one piece of data. There's 3 data here, and there's 2 data here. And again, your goal with stem plots or dot plots is to see if you can find some sort of shape to it. The shape, as we get more and more information, will go along with something called a normal curve. Yes, the normal curve can be skewed to the left, it could be to the right, but the normal curve is just the indicator of what your data shape is, and the normal curve becomes basically the foundation of everything for statistics that we will deal with in the class, okay? So, dot plots are not hard to make. Stem plots are not hard to make. When you look at the data on page 12, if you were looking at their fuel economy of random samples of 2015 model year cars, what does each dot represent? It represents a car of some sort, or the gas mileage of a car. How many observations are in the data set? You would count up all your dots. So if we counted the dots on page 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16 pieces of data in there. The highest observation would have been 40 miles per gallon, I guess it is. And the lowest would be 16 miles per gallon. And then stem plots, dot plots require a smaller number of observations, but they maintain the entire data set as part of the display. And then we've already discussed bar charts. We talked about circle charts, histograms, stem plots, and dot plots now. There are more and more and more of ways of looking at the data. It becomes, all we look at is how can we change our data to make it fit. So 1, 5, 1, 5. All right, so I'm going to give you the opportunity to work on page 109 and 110, okay? And I'm going to stop recording now.